Base and orthogonal rate system, conversions, and chip formation. And we have discussed about the different types of chips produced during the process of machining. And we are done with discontinuous chips. Now put subheading continuous chips. See, all of you take the diagrams neatly, write them properly. All the points and conditions, whatever I'm dictating you, are very, very important. There is every possibility of getting 1 mark questions out of this concept. Put subheading continuous chips. Continuous chips. Continuous chips. Write down. These are generally produced. These are generally produced when ductile materials are machined. When ductile materials are machined under the following conditions. When ductile materials are machined under the following conditions. And ductile materials are machined under the following conditions. Next. Right on. First one. Higher cutting speeds. Higher cutting speeds. Large rake angles. Large rake angle. Large rake angle. And low depth of cut. Low depth of cut. I repeat, higher cutting speeds, large rake angle, and low depth of cut. Now you please draw this diagram, this one. Please let me know once you are done with the diagram. over next write down. Continuous chips are difficult to handle. Continuous chips are difficult to handle. Continuous chips are difficult to handle and to dispose of. Difficult to handle and to dispose of. Thereby, thereby, chip breakers are employed. Thereby, chip breakers are employed. Chip breakers are employed. Chip breakers are employed. Next, chip breakers are employed. You just draw this diagram. Take a rough sketch of this. Make it fast. హలో టాప్స్ అన్నీ కూడా నీకు రేట్ డౌట్ వస్తాయి ఇంటూ 1.1 అని వచ్చేస్తుంది. క్లాస్లో ఉన్నాను. Done. See, please, any somebody, unmute and tell me. Sagar,
Yes, sir.
over.
Yes, sir.
Next, put subheading. Continuous chips with built-up edges. Continuous chips with BUE. BUE stands for built-up edges. BUE stands for built-up edges. Continuous chips with built-up edges. Under that, write down. When ductile materials are machined, when ductile materials are machined, when ductile materials are machined, continuous chips are produced. Continuous chips are produced. Continuous chips are produced. Full stop. When chip flow is continuous along the face of the tool, when chip flow is continuous along the face of the tool, heat generation becomes maximum. Heat generation becomes maximum along chip tool interface, along the chip tool interface due to frictional forces. Due to frictional forces. Frictional forces. Frictional forces. At this point, tiny work particles. At this point, tiny work particles start accumulating. Tiny work particles start accumulating. Start accumulating along chip tool interface. Along chip tool interface and as well as the cutting edge. As well as the cutting edge. Stop. This accumulation leads to the formation of built-up edges. This accumulation leads to the formation of built-up edges. Full stop. Though the cutting edge, next point, though the cutting edge is protected by BUE, though the cutting edge is protected by BUE from the intense heat, though the cutting edge is protected by BUE from the intense heat generated during machining during machining, comma, built up edges are treated as undesirable. Built up edges are treated as undesirable because because they are the source of vibrations. They are the source of vibrations. Full stop. To avoid the formation of built-up edges, machining should be carried out under the following conditions. Machining should be carried out under the following conditions. Machining should be carried out under the following conditions. Right on, first one. Higher cutting speeds, higher cutting speeds, large rake angle, large rake angle, low depth of cut, low depth of cut. Next, by using EP fluids, by using EP fluids, right within brackets. EP means extreme pressure cutting fluids. Extreme pressure cutting fluids. EP fluids means extreme pressure cutting fluids. Now you draw this diagram.
Sir, completed.
Um, put subheading, put subheading, thermal aspects of metal cutting. Thermal aspects of metal cutting. thermal aspects of metal cutting. Food subheading thermal thermal aspects of metal cutting. Thermal aspects of metal cutting. Thermal aspects of metal cutting. First, draw this diagram.
Completed, sir.
Now look at the diagram. Now in this case, we know that this is the rake face and this is the cutting edge. So we know that material in machining process is always removed along the shear plane, along the shear plane. Therefore, maximum amount of heat is generated along the shear plane. Maximum amount of heat is generated along the shear plane, and thereby we treat this as a primary heat generating zone or a primary deformation zone. Primary heat generating zone. And in machining process, whatever the heat that is generated along the shear plane, considerable amount of heat is carried away by chip flow. Considerable amount of heat is carried away by chip flow. And when there is a continuous chip flow along the face of the tool, due to frictional forces, heat generation along chip tool interface becomes maximum. Therefore, Chip tool interface, heat generation along chip tool interface is treated as a secondary deformation zone or secondary heat generating zone. And when harder metals are machined, heat generation along at the flank area just below the cutting edge is going to be maximum. And this is treated as a tertiary heat generating zone. So this is primary heat generating zone, secondary heat generating zone, and this is tertiary heat generating zone. And now when you look at the total amount of heat generated during the process of machining, heat carried away by chip flow, heat carried away by chip flow, heat heat passed into the tool, heat remaining in the workpiece, and heat lost to surroundings. Now write down. Write down. Total heat generated is equal to, write down, total heat generated is equal to, total heat generated is equal to heat carried away by chip flow, heat carried away by chip flow, heat carried away by chip flow plus heat passing into the tool, heat passing into the tool, heat passing into the tool plus heat remaining in the work, heat remaining in the work plus heat lost to surroundings, heat lost to surroundings, heat lost to surroundings, heat lost to surroundings. Next, put subheading, put subheading, methods of metal cutting. Methods of metal cutting. Methods of metal cutting. Now look at the screen. So there are two different types of metal cutting operations. One is orthogonal cutting. Second one is oblique cutting. Orthogonal cutting. Second one is oblique cutting. Now, in case of orthogonal cutting, ortho means what? Perpendicular, 90 degrees. So cutting edge of the tool in orthogonal cutting, cutting edge of the tool makes 90 degrees with the direction of tool feet. This is tool feet, direction of tool feet. So this cutting edge makes 90 degrees with the direction of tool feet. And this part we call it as depth of cut. And in case of oblique cutting, cutting edge of the tool makes an acute angle with the direction of tool feet. This is acute angle, less than 90. Makes an acute angle with the direction of tool feet. Write down. Under methods of metal cutting, write down. There are two types. There are two types. First one, orthogonal metal cutting. Second, oblique metal cutting. Orthogonal metal cutting. Second one is oblique metal cutting. Put subheading orthogonal metal cutting. Put subheading orthogonal metal cutting. Write only one point. Orthogonal metal cutting. In this, cutting edge of the tool makes 90 degrees with the direction of tool feed. Cutting edge of the tool makes 90 degrees with the direction of tool feed. Next, leave space for the diagram. Leave space for this diagram. Look at the screen. This is orthogonal cutting. Now leave space for the diagram and put subheading oblique metal cutting. Oblique metal cutting. Under this, write down only one point. In this, in this, cutting edge of the tool makes cutting edge of the tool makes an acute angle. Cutting edge of the tool makes an acute angle with the direction of tool feed. Makes an acute angle with the direction of tool feed. Under this, draw this diagram. Under oblique cutting, draw this diagram. Under orthogonal cutting, draw this diagram. Draw the diagrams.
Sir, diagram completed. Okay, sir. Completed, sir.
Done.
Yes, sir.
Next, puts up at cutting fluids. Cutting fluids. Now, can you tell me some of the desirable properties of cutting fluids? Cutting fluids ఉండాల్సిన desirable properties ఏంటి?
High heat carrying capacity.
Very good.
Higher viscosity.
Ah, ఇంకా ఇంకా I'll tell you. Cutting fluids should act as a lubricant, should act as coolant, able to flush away the chips from the metal cutting zone, and they should have high flash and fire points. These are some of the very important desirable properties of the cutting fluids. So cutting fluids are of two types. One is soluble oils, the second one cutting oils. Soluble oils are mixed with water, where water acts as coolant and oil acts as lubricant. And the best example for soluble oils is soap water. Soap water. And the next one is cutting oils. Cutting oils should never be mixed with water. And these cutting oils are of two types. One is fixed oils, and second one is mineral oils. So fixed oils include all vegetable oils, whereas mineral oils are extracted from petroleum crude. And fixed oils would have more lubricating properties, whereas mineral oils are more stable than fixed oils. And I told you, cutting oil should never be mixed with water, but these two oils, fixed and mineral oils, can be mixed together and used as cutting fluids to get the advantages of both these oils. And um, sometimes EP fluids are sometimes EP additives are mixed with cutting oils, and such type of oils are called as EP fluids or extreme pressure cutting fluids. And objective of these fluids is to avoid the formation of built-up edges during the process of machining. Right on. The desirable properties of cutting fluids are desirable properties of cutting fluids are desirable properties of cutting fluids are right on. First one should act as coolant, should act as lubricant, should act as coolant, should act as lubricant. Next, able to flush away, able, able to flush away the chips, able to flush away the chips from metal cutting zone, able to flush away the chips from metal cutting zone, able to flush away the chips from metal cutting zone, able to flush away the chips from metal cutting zone. Next, should have high flash and fire points, should have high flash and fire points, should have high flash and fire points. should have high flash and fire points. Next, cutting fluids are of two types. Cutting fluids are of two types. First one, first one, soluble oils. Second, cutting oils. Soluble oils. Second one, cutting oils. Cutting oils. Put subheading soluble oils. Soluble oils. Under that, write down. These are mixed with water. These are mixed with water. These are mixed with water. These are mixed with water where these are mixed with water where water acts as coolant. Water acts as coolant. Oil acts as lubricant. Oil acts as lubricant. Oil acts as lubricant. Oil acts as lubricant. Next. Oil acts as lubricant. Oil acts as lubricant. Example, soap, water. Soap, water. Next, put subheading, cutting oils. Cutting oils. Cutting oils. Cutting oils. Right on. These oils should never be mixed with water. These oils should never be mixed with water. Should never be mixed with water. Full stop. These are of two types. These are of two types. First one, fixed oils. Second, mineral oils. Fixed oils. Second one, mineral oils. Fixed oils. Second one, mineral oils. Fixed. Second, mineral oils. Fixed oils include, next point, right on. Fixed oils include all vegetable oils, all vegetable oils, whereas mineral oils are extracted from petroleum crude. Next point, fixed oils would have better lubricating properties. Fixed oils would have better lubricating properties, whereas mineral oils are more stable. Whereas mineral oils are more stable than fixed oils. Next, fixed and mineral oils can be mixed together. Fixed oils and mineral oils can be mixed together can be mixed together, can be mixed together and used as cutting fluid and used as cutting fluid to get the advantages of both. To get the advantages, to get the advantages of both. Next, sometimes EP additives sometimes EP extreme pressure additives such as sulfur, chlorine are added to cutting oils. Sulfur, chlorine are added to cutting oils, and such type of oils are called as sulfonated oils or EP fluids. Such type of oils are called sulfonated oils or EP fluids. The main objective of these fluids, is to avoid the formation of built-up edges. Is to avoid the formation of built-up edges. Avoid the formation of built-up edges. Done, all of you?
Yes, sir.
Now look at the board. Look at the screen. Chip thickness ratio smaller. Chip thickness ratio smaller. It is represented with smaller. Now look at the diagram. So this is alpha is rake angle and this beta is shear angle. This is chip and this is tool. So T1 represents the thickness of the chip before cutting and T2 represents thickness of the chip after cutting. So chip thickness ratio R is given by T1 by T2. Chip thickness ratio is equal to T1 by T2. Where T1 is what? Thickness of the chip before cutting. T2 thickness of the chip after cutting. And the chip thickness ratio is always less than 1. Now do one thing. Put subheading chip thickness ratio, draw this diagram neatly and take down this formula. Draw the diagram, take down this formula. ఇక్కడ ఇవన్నీ జాగ్రత్తగా రాసుకోకపోతే we cannot solve any problem from machining.
Sir, completed.
Done. Have you taken
Yes,
this
sir.
formula? R is equal to T1 by T2.
Yes, sir.
Right on. Where T1 is thickness of the chip before cutting. Write down that. T1 thickness of the chip before cutting. T2 T2 thickness of the chip after cutting. T1 thickness of the chip before cutting. T2 thickness of the chip after cutting. Next, under that add one more point. Chip thickness ratio, chip thickness ratio or cutting ratio, both are same. Chip thickness ratio or cutting ratio is always less than unity. Is always less than unity. Is always less than unity. Done.
Yes, sir.
Now put subheading chip reduction coefficient K. Chip reduction coefficient K. Chip reduction coefficient K. Now look at this diagram. So this is work and this is chip. This is work, this is chip. Now this is L. I have written L, but it is L1. I forgot to write 1. L1 and this is L2. L1 is what? Length of the work, and this L2 is length of the chip. Means L1 is length of the work, means before cutting, and L2 is after cutting. Now chip reduction coefficient is given by L1 by L2. Chip reduction coefficient K is equal to L1 by L2. So what is L1? Length of the chip before cutting. L2 length of the chip after cutting. Now put subheading chip reduction coefficient K. Chip reduction coefficient K. Draw the diagram and take down this formula. So don't forget here, write down L1, not L. This is L1.
Sir, done, sir.
Done. Right on. Where L1 is length of the chip before cutting. L1 length of the chip before cutting. L2 length of the chip after cutting. L2 length of the chip after cutting. Length of the chip after cutting. Now draw this diagram, and before that put subheading shear angle. Sorry, put subheading shear angle. Shear angle beta. Shear angle beta. ఒకసారి సరిగ్గా చూడండి to look at the diagram. This is tool chip T1 and this is T2, same as the previous diagram. This is shear plane OP. I have dropped down a vertical which makes 90 degrees, and I write here A. One horizontal from P to meet B, and this also makes 90 degrees with this. And this PB is equal to T2 and PA is equal to T1 automatically. Now, this is 90 degrees. If this is beta, beta shear angle. If this is beta, what is this? 90 minus beta, correct? Now look at this right angle triangle. What is this inclination? This is vertical, we know, and this is alpha. So this whole thing is 90 degrees. 90 degrees, this whole thing is 90 degrees. So what is this? What is only this part? Sorry, this is 90 degrees. This is 90. I've written wrong. This inclination is from here to here. From here to here. ఇక్కడ నుంచి ఇక్కడ వరకు, because we are considering the triangle OBP. OBP. In OBP, this is 90, and what is this inclination? From here to here it is 90. So 90 minus beta is not there. So 90 minus beta plus alpha. You should consider this also. This also. 90 minus beta plus alpha. So take minus outside, then it becomes 90 minus beta minus alpha. If this is 90 and 90 minus beta minus alpha, then this becomes beta minus alpha. First you draw this diagram. Draw this diagram.
Completed.
Done. Just before, we have seen R is equal to what is R? Chip thickness ratio, that is equal to T1 by T2. And what is K? Chip production coefficient, that is equal to L1 by L2. L1 by L2. Now, during the process of machining, volume of chip cut is equal to volume of the chip. Means before cut is equal to after cut. So, ఇది నార్మల్గా ఎలా ఉండాలి? వాల్యూమ్ ఆఫ్ చిప్ కట్ ఎంత కట్ చేద్దాం అనుకున్నామో కట్ చేసిన తర్వాత కట్ చేసిన బిఫోర్ అండ్ ఆఫ్టర్ షుడ్ బి సేమ్ కదా. సో వీ హ్యావ్ టేకెన్ B1 L1 T1 is equal to B2 L2 T2. What is B1? Width of chip. Width of chip. But in metal cutting operation, always width is assumed to be constant. Means B1 is equal to B2. So metal cutting width is always assumed to be constant. Therefore, B1 and B2 gets cancelled here, and it becomes L1 T1 is equal to L2 T2. L1 T1 is equal to L2 T2. Now L1 T1 is equal to L2 T2. So దీనిని మనం ఎలా రాయొచ్చు? So T1 sends T2 to this side and L1 to this side. So T1 by T2 is equal to L2 by L1. T1 by T2 అంటే ఏంటి? What is T1 by T2? Small r అనా?
R, sir. Small r.
Small r. మరి దీన్ని మనం ఎలా రాయొచ్చు? L1 by L2 is equal to T2 by T1 అని కూడా రాయొచ్చా?
Yes.
So we can also write this equation as L1 by L2, send this L2 to this side, and this T1 to this side. Then it becomes L1 by L2 is equal to T2 by T1. So L1 by L2 is equal to what? K. Antena?
Yes,
What
sir.
happened? Now, so from these two expressions, we can write the relationship between chip thickness ratio and chip production coefficient. R is equal to 1 by K or K is equal to 1 by R. అర్థమైందా?
Okay, sir.
Very important. How we take down? Now take down this.
Completed, sir.
Next. Now take down this continuation. Over.
Yes, sir.
Next.
Done, sir.
Done.
Yes, sir.
Uh, Now look at this diagram. Look at this diagram. So from triangle, consider triangle OAP. Consider this triangle. Sine beta can be written as what? What is sine beta in this triangle? Sine beta. Huh? Sine beta ఎంతమ్మా? In this triangle OAP, sine beta is equal to AP by OP. AP is what? T1. Is it? And beta is equal to T1 by OP. OP. As OP can be written as OP, send this OP to this side, then becomes T1 by sine beta. Take it as 1. Equation 1. From triangle BPO, look at the diagram. From triangle BPO, cos beta minus alpha. What is cos beta minus alpha? Cos beta minus alpha.
T2.
PB by OP. PB and
OP.
anta T2. So
PB T2, sir.
T2.
T2.
Cos beta minus alpha is equal to T2 by OP. OP. And send this OP to this side. Then it becomes T1 by cos beta minus alpha. Take this equation as 2. So OP has this equation and this equation. So equate 1 and 2. Equate 1 and 2. Then it becomes T1 by sin beta is equal to T2 by cos beta minus alpha. Now send this T2 to this side and sin beta to this side. Then it becomes T1 by T2 is equal to sin beta by cos beta minus alpha. T1 by T2 అంటే ఏంటి?
R.
R. అంతేనా?
Yes, sir.
సో మనం గుర్తుపెట్టుకోవాల్సింది ఏంటి? R is equal to T1 by T2 కాకుండా that is also equal to
Sin beta by cos beta minus alpha.
sin beta by cos beta minus alpha. మరి T1 T2 లేకుండా ప్రాబ్లంలో బీటా ఆల్ఫా ఇచ్చాడు అనుకోండి. ఇఫ్ దే ఆస్క్ యూ టు క్యాలిక్యులేట్ ఆర్, అప్పుడు ఎలా కనుక్కోవాలి మనం? యూజింగ్ దిస్ ఫార్ములా sin beta by cos beta minus alpha. What is R? Sin beta by cos beta minus alpha. Now sin beta by cos beta minus alpha is equal to R. Okay na? Now I write it as sin beta is equal to send this cos beta minus alpha to this side. Then it becomes sin beta is equal to R cos beta minus alpha. Sin beta is equal to expand cos beta minus alpha. R cos beta cos alpha plus R sin beta sin alpha. Then divide both sides with cos beta. Then sin beta by cos beta becomes tan beta. And cos beta gets cancelled. So it becomes R cos alpha. And here sin beta by cos beta becomes tan beta. R tan beta sin alpha. అర్థమవుతుందా అందరికి?
Yes, sir.
అండర్స్టాండింగ్? Next tan beta is equal to R cos alpha plus R tan beta sin alpha. Now tan beta, send this R tan beta sin alpha to this side. Now it becomes a tan beta minus R tan beta sin alpha is equal to R cos alpha. Now take tan beta common. అప్పుడు ఏమవుతుంది మనకి? tan beta into 1 minus R sin alpha is equal to R cos alpha. Now tan beta is equal to R cos alpha by 1 minus R sin alpha. Tan beta is equal to R cos alpha by 1 minus R sin alpha. Am I clear?
Yes, sir.
So what is beta? Beta and ఏంటి?
Beta rake angle.
Shear angle. Alpha is rake angle. Beta is what? Shear angle. So when somebody asks you to calculate beta, shear angle, so this is the formula to use. అర్థమవుతుందా? చాలా 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 ఇంపార్టెంట్. రాసుకో. So take down this continuation.
Completed, sir.
Hmm.
Done, sir.
Done.
Completed, sir.
Done.
Yes. Completed, sir.
Now put subheading merchant circle diagram. Merchants circle diagram. Now look at the screen. See here, beta shear angle. This is Fs. Fs is shear force, Fc cutting force, Fe feed force or thrust force, resultant force, and Fn is force normal to shear force, and P is frictional force, N is normal force, gamma friction angle, beta shear angle, alpha rake angle. First, you draw this diagram. This is Mathian circle diagram. Draw this first. Draw this diagram neatly. Over.
Yes, sir.
Now you write down. Take down. Under the diagram, write down. Fc cutting force, Fs shear force, Fn force normal to shear force, Fe feed force or thrust force, R resultant force, P frictional force and normal force, alpha rake angle, beta shear angle, gamma friction angle.
Completed, sir.
Completed.
Yes, sir.
Now you draw this diagram. Just a moment. Just a moment. Uh, just a moment. See, draw this diagram. Draw this diagram. Inclinations are very important. జాగ్రత్తగా చూసి డ్రా చేయండి.
Sir, completed.
So look at this diagram. So this is Fs means shear force, and Fn is force normal to shear force, beta shear angle, and this is gamma friction angle, Fc cutting force, Fe feed force. ఒక్కసారి చూడండి. So we extend AB shear force up till C, and from C we drop down a normal to meet D. This inclination BCD, this inclination is 90 degrees. This is 90. Okay. Now we drop from point D, we drop down a vertical to meet BE at G, and this also makes 90 degrees with BE. Now DG and BC both are equal and parallel to each other. BC and DG, these two are parallel to each other and equal to each other. Next, GB and CD, GB and CD both are parallel to each other. GB and CD parallel to each other and both are equal. Now look at here. So this is gamma. This is gamma. And we know that FC and FV, this is 90 degrees. 90 degrees. We know AC and DG both are parallel to each other. They are parallel to each other. So when they are parallel to each other, and AD is the connecting line of these two parallel lines. Now if this inclination is beta, this inclination would also be beta. And now as this is 90 degrees, this inclination would be 90 minus beta. Now look at the triangle DGE. Triangle DGE. In triangle DGE, this is 90, 90 minus beta. Now this becomes beta. ఏమో అర్థమవుతుందా యాంగిల్స్ ఎలా వస్తున్నాయో?
Yes, sir.
Now this is gamma. ఇది గామా అయింది అనుకోండి, ఇది 90 degrees మనకు తెలిసిందే. This is gamma. Now in the triangle AHE, 90 degrees and this is gamma. ఇది ఎంత అవుతుంది? 90 minus gamma.
90 minus gamma.
Now what is this? What is inclination DAE? What is this inclination? Gamma minus alpha. అది ఎలా వస్తుంది? This total inclination is 90 degrees కదా, ఇక్కడ నుంచి ఇక్కడ వరకు. From here to here up till alpha, including alpha, this is 90. Now what is this? 90 minus gamma minus alpha. 90 లోంచి 2 తీస్తే ఇది వస్తుంది. ఓకే, 90 minus gamma minus alpha. 90 minus 90 minus gamma minus alpha. 90 gets cancelled. Okay, 90 gets 90 gets cancelled, and minus into minus plus, gamma becomes plus and this becomes minus. So gamma minus alpha, this becomes gamma minus alpha. Okay, so these are the inclinations. Inclinations ఎలా వచ్చినాయి అర్థమైందా? All of you? Sagar and Shishkumar. Now let's see. Now Fs ఎలా వస్తుంది? Can we write Fs is equal to AC minus BC? Look at the diagram and tell me. AC minus BC is equal to Fs, right, sir?
Yes, sir.
So Fs is equal to AC minus BC. Now, how to find out AC and BC? So from triangle ACD, diagram loan, from triangle ACD, cos beta is equal to AC minus AD, right, sir? From triangle ACD, ఈ triangle చూడండి.
Yes, sir.
Cos beta, cos what is cos beta? AC minus, AC by
AD.
AC by ఏడి.
AD.
మనకి ఏసీ కదా కావాలి, ఏసీ బై ఏడి. ఏడి అంటే ఏంటి? ఎఫ్సి కదా.
Yes, sir.
నా వీ కెన్ రైట్ ఇట్ యాజ్ ఏసీ బై ఏడి. నా ఏసీ ఈజ్ ఈక్వల్ టు ఏడి ఇంటూ కాస్ బీటా. ఏడి అంటే ఏంటి? ఎఫ్సి. Now AC is equal to FC cos beta. Now look at triangle DEG. Triangle DEG. Now triangle DEG. In this triangle DEG, sin beta is equal to DG by DE. Sin beta is equal to DG by DE. DE means what? FV. DG
FC.
is equal to BC. ఇందాక చెప్పుకున్నాం కదా.
Yes, sir. Same distance.
Equal to BC. So DG plus to BC and రాసుకోవచ్చు కదా మనం.
Yes, sir.
So sin beta is equal to DG by DE. DG is nothing but BC. BC by DE is nothing but FV. Now BC is equal to FV sin beta. Kada? Now FS can be written as AC and ND. FC cos beta.
FC
BC
cos
and ND.
beta.
FV
FV
sin beta. Antena?
Yes, sir.
Now Fs is equal to Fc cos beta minus Fv sin beta. Fc cos beta, Fv sin beta. You please take down this.
Completed.
Now, have you written this? Fs is equal to final Fs is equal to Fc cos beta minus Fv sin beta. Fc cos beta minus Fv sin beta. Over?
Yes, sir.
So are you comfortable with the discussion happened today so far?
Yes, sir.
All right, we shall stop it here for today. So meet you in the next class. Thank you.